Okay, today's video we're going to learn about mathematical identities. And mathematical identities are a huge part of math that oftentimes goes overlooked and not addressed. And these identities that we're going to talk about today are identities that you're very familiar with seeing and understanding intuitively. So we're just going to define them today so that we know what they look like. Our learning target today is to identify the different identities and the different forms that they may appear. Before we get into the specific identities, let's just kind of define what an identity is. An identity is an equality relation or an equal relationship, a relationship that is equal, that is always true. So the relationship will always be true no matter what values you have in the relationship or variables. And a common example of this is x plus 0 equals x. So no matter what value x equals or what number x represents, both sides of this equation will always be equal to each other. So let's just say x for whatever reason equaled 1,202, right? If we plugged in 1,202 to both of the x's and we simplified both sides, so 1,202 plus 0 is just 1,202, and that equals 1,202. This identity here will always result in a relation that is true. So let's get into the first mathematical identity, and we kind of just talked about it, but the additive identity is one of the most common identities that you see in algebra. And what that is adding 0 to a number or a variable leaves it unchanged. So you can see here we've got the identity in words. Go ahead and transfer that into your notebook, and then transfer the identity in math into your notebook as well. A plus 0 equals A. So adding 0 to this A does not change the value of A. Another example that you see is with numbers. So 5 plus 0 equals 5. Adding 0 to 5 does not change its value. And then subtracting 0 as well. So 5 minus 0 also equals 5. So this identity is either adding or subtracting 0 does not leave the value unchanged. And you could see it like this too sometimes. 0 minus 5, right? And we know that this minus 5 is the same thing as a negative 5 equals a negative 5. Okay, and this is what the additive identity is. The second identity that I would like to talk about is the additive inverse. The additive inverse is opposite numbers add up to 0. So you can see here we have a positive A and we've got a negative A, and when we add these together they add up to 0, and they will always add up to 0 no matter what the opposite numbers or variables are. So another example would be negative 2 plus positive 2, these are opposite numbers, equals 0, right? And then the same thing is true when you subtract the same number. So you can add the opposite number, or the additive inverse is also sometimes presented in subtracting the same number. So an example of that would be 3 minus 3 equals 0. And a non-example of this, something that is not the additive inverse, this is a non-example, would be adding the same number. So x plus x does not equal 0, that equals 2 x's. So adding the same number does not equal 0. And the same thing is true with subtracting a negative number. So 3 minus a negative 3, this also does not add up to 0. So these two do not meet the definition of the additive inverse. The third identity that I want to discuss is the definition of subtraction. And the definition of subtraction is adding a negative is equivalent to subtracting. So you can see here a plus a negative b, this plus a negative, is the same thing as just saying A minus B. So you can condense this double sign plus a negative to subtraction. So a common example would be when you see that double sign, plus 5 plus a negative 2 equals 5 minus 2, and both of these sides would simplify to 3. So 3, if you have $5 and you add a negative, or you add debt to your $5, you take away $2 from your 5, you have 3. 5 minus 2 is also 3. So these two things are the same. So a lot of times we can take this double sign and we can condense it to subtraction, but sometimes in math it's helpful to take the subtraction and expand it to adding the negative. So 2x minus 3 can be rewritten as 2x plus a negative 3. So sometimes we want to take that subtraction and add the negative because it kind of helps us visualize. So these are two examples of the definition of subtraction. And a non-example of this would be 2x minus a negative 3 does not equal 2x minus 3. These do not equal each other. They are not the same thing. You cannot take a double negative and condense it to just subtraction. Double negatives are not subtraction. Just a plus and negative is. The fourth identity that I want to talk about is the multiplicative identity. And this identity is multiplying a number or a variable by 1 leaves it unchanged. So very similar to adding 0 to a number or a variable leaves it unchanged. The same thing is true when you multiply a number or variable by 1. So a times 1 equals a is the math definition for the multiplicative identity. And oftentimes you'll see this lots of different ways. So one example, sorry, I shouldn't be using red, I should use blue. These are examples. Would be if you have 1x. Oftentimes students are confused by this. 1x is the same thing as just x by itself. You do not need to write the 1 because multiplying this 1 to x leaves it unchanged, so we can just leave it as x. Or sometimes we'll have negative 1 times y squared. We do not need to write the times 1. We know that multiplying by 1 will not change the value of y squared, so we can just rewrite this as negative y squared and not have to multiply the 1 to it. And then the last example I kind of want to show you is if we had negative 1 times x plus 3. So you might see an example like this, and this is the same thing as just writing negative x plus 3, where we don't need to show that the 1 is being multiplied because it's not going to change the value of what we're multiplying it to anyways. Also very important to note that when we have fractions, so let's say we had the fraction 5 over 3, and we wanted to add this to 4 over 2, we've got to find a common denominator, and what we end up doing here is actually using this multiplicative identity to get that common denominator. So for example, we would common denominator here would be 6, so we need to get 6 in the denominator. We would multiply this 5/3 by a 2 over 2, and you know that 2 divided by 2, or anything divided by itself, is actually 1. So we're actually multiplying this fraction by 1. We're not changing the value of 5/3, we're just changing the way that it appears. So we've got 10 over 6. And then on the 4 over 2, we would multiply this by a 3 over 3. And we know that 3 divided by 3 is 1, so we're not changing the value of 4 divided by 2, or 4 seconds. We're just changing the way it appears to 12 over 6, so that now we can add these fractions. So you're very familiar with the multiplicative identity. You've used it a lot, but now it's just a matter of identifying when it's being used or not being used. The next identity that I want to discuss is the multiplicative inverse, and this is just another name for reciprocal. So when you multiply a number by its multiplicative inverse, the outcome will always equal 1. And you can see here we've got a, and if we wanted to, we could write a over 1, right? Normally we don't write the denominator when the denominator is 1. We've got a over 1 times 1 over a, so you can see that they're reciprocals of each other. We've flipped the denominator and the numerator, and when you multiply reciprocals together, they will always equal 1. So an example here would be if we had 5 over 3, and we multiplied that by the multiplicative inverse, which would be 3 over 5, right? They equal 1. Or if you had, negative 9x over y, and you multiply that by a, y over a negative 9x, these are reciprocals of each other, and they will always multiply to equal 1. Or just even more complicated example, if we had, x plus 2 over x minus 5, and we multiplied this by x minus 5 over x plus 2, you can see here we're multiplying by the reciprocal. They're going to equal 1. So this is the multiplicative inverse that we oftentimes see in math. The last identity today is just the definition of division. So in math, really, you only have addition and multiplication, but we've come up with subtraction and division as shortcuts for adding the opposite, which is the same thing as subtraction, and then for division, it's multiplying by a value in the denominator with 1 in the numerator. So you can see here a times 1 over b. You can see the value here, b is in the denominator, and we've got 1 in the numerator. This can be rewritten as, this multiplication can be rewritten as just division, just a divided by b. And that makes sense to us because when we multiply fractions anyways, we multiply straight across. And you can see a times 1 is just a, because the multiplicative identity, anything times 1 is whatever you're multiplying to 1, which is a. And 1 times b, the multiplicative identity, is just b, so it's really just a divided by b, or another way of writing that would be a over b, like this, right? So multiplying by this denominator with a value and a numerator of 1 is the same thing as just dividing. So another example of this would be if you had 100 times 1 over 25, 1/25. This is the same exact thing as just saying 100 divided by 25, right? Because 25 is in the denominator and we've got 1 in the numerator, which is the same thing as just saying 4. Another example that you might see is, if you've got x divided by 4, you can rewrite this as x times 1/4, which is the same thing as just saying 1/4 times x. So you can take division, you can actually turn it into multiplication if you want by using this this identity, which is just the definition of division. A non-example of this would be, a common non-example would be if you had 100 times 3 over 4. You cannot say that this is 100 divided by 4 because you do not have 1 in the numerator. So this is very important. You can only turn multiplication into division or division back into multiplication if 1 is in the numerator.
Mr. Criddle,
Or x divided by 4 does not equal 4x. You can't take what's being divided and multiply it. You can only turn this into multiplication if you have 1 in the numerator. So that's an important part of this definition of division.